We want to prove the identity sin A over 1 plus cos A plus 1 plus cos A over sin A is identical to 2 over sin A. We're going to start with the left-hand side for no other reason than that the left-hand side looks like we can do the most with it. The left-hand side is sin A over 1 plus cos A plus 1 plus cos A over sin A. I'm going to add these fractions. If we had a numerical example such as 3/7 plus 2/5, then we'd take a common denominator of 35, since this is 7 times 5. The 3 would then get multiplied by this 5, and the 2 by this 7. We're going to do the same thing here. The common denominator will be sin A times 1 plus cos A this sin A will get multiplied by this sin A, giving us sin squared A, and the 1 plus cos A times the 1 plus cos A gives 1 plus cos A squared. Expanding the bracket on the top so the denominator stays the same as sin A over 1 plus cos A, we have our sin squared A, and the 1 plus cos A all squared is 1 plus 2 cos A plus cos squared A. We're going to tidy the top so the denominator again stays the same. Sin squared plus cos squared we know is 1. Added onto this one gives us 2. So we get 2 plus 2 cos A. Taking out a common factor of 2, we get this expression, and we can now see that the 1 plus cos A will cancel, leaving us with 2 over sin A, which is the same as the right-hand side. So we've proven our identity.